right. Hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. This is another worksheet on multiplying polynomials, but kind of like, what they're saying here, special case, like there's kind of a shortcut. So this is really if you want to like save time, or if your teacher's like making you do this or whatever. There's really only like two kinds of these. You'll look like number one, it's x plus 5, x minus 5. Same thing for number two, it's a plus minus, right? So it's like the same thing in the front, same thing at the end, and then a different sign in the middle, right? So that's 1 and 2 and 4 and 7, 10, 12, 13, 14, 16. You get the picture, right? So it's the same two things, but with a different sign in between. Okay, there's that. And then there's number 3, or 5, or 6, 8, 9. Where's one where they don't write it out as a square? 11, 15. Trying to see where they write it out as not a square. I don't see any of those. They look like they're all squares. Sometimes they might write it out like they did for number 1 or 2, but it'll be like the same thing. Like for number 1, let's say if it was a square but they didn't write it as a square, they might write it as x plus 5, x plus 5. So it'll be x plus 5 times x plus 5. So if they do that, it's the same thing as number 3, and we'll see why in a second. But let's go ahead and look at what to do with these kinds of things here. So for number 1, this is what's called conjugates. When you have the same thing, right? So a conjugate, a conjugate, a conjugate, conjugate. That's the fancy word for when you have the same first number, the same last number, and a different sign in between. Okay, when that happens, those are called conjugates. So what you do with those is you square the first term, right? So this thing right here, we'll call that a. We'll call that a. So you do a squared, and then you've got this other guy over here. We'll call that b. So actually, let me use a different shade of blue or something here, or maybe just a different color altogether. That might work better. Let's do it. Let's do red. So this guy right here will be b. Okay, so the first thing we're going to call that A, the second thing we're going to call that B, and they might use A's and B's as letters in the future, but, these are, just theoretical A and B, nothing in particular. So basically what happens is both of those are going to be squared, and then what goes in between, I'll use purple for in between, since red and blue make purple. That's supposed to be a minus sign. We get this. So basically, what you do is you have A and B. So you just identify where the first thing is and where the second thing is. And then you'll have a minus sign in between. And that'll happen no matter what. So that'll happen if you have, a negative in front. Let's say it was like negative x plus 5 and then negative x minus 5. It'd still be the same thing. It'd still be the same thing because it's negative x times negative x, so it's positive. And then you would still have like different signs in between. You'd still have a plus and a minus 5x. Okay, so since that's the case, it's always going to be like this. It's always going to be a squared minus b squared, right? And then if you've maybe done anything with factoring, then you might notice that a squared minus b squared, that's a difference of squares. And then you can factor that into the conjugates. So if you've already done factoring, then you've maybe seen this as well. Right? And that's how all of these are going to go. So I'm going to switch back to blue here. Switch back to blue. And we have x squared, right? Minus. And then 5 squared is 25. That's the answer. And that's it, right? So we do the same thing each time. So this is just going to be n squared. Square the n. 1 squared is 1. And there's a minus sign in between. So that's it, right? And let's go ahead and do number 4 since it's kind of the same thing here. X squared, right? X times x. 3 times 3 is 9, aka 3 squared. And we're done with that one as well. Okay? Now, so that was conjugates. When you have a square, like a term that's squared, like this, let's look at what to do then. So maybe we'll use blue and yellow. So when you have the a term here and the b term here, what's going to happen is you have to FOIL it now. So you kind of have to FOIL it before. Like if we FOILed out number 1, it would be first times the first, so x times x, x squared. Outer times the outer, so x times negative 5, so negative 5x. Inner times the inner, 5x. Oh, negative 5x and 5x cancel. So the inner terms always cancel with conjugates. That's why you can just do a squared minus b squared. With squares, the middle terms always combine so that there's 2 of them. So when you have squares, right? So for squares meaning like, you know, square powers, you do a squared, right? And then I'm going to use green for the middle. A squared plus 2ab, and then yellow for the end, plus b squared. Right? So it's a squared and b squared again, but we don't necessarily have a minus sign in between them. And actually, b squared is always going to be positive because you're going to be multiplying it by itself. So it's always going to be a positive. Because if you take a negative times a negative, you get a positive. If you take a positive times a positive, you get a positive as well. So b squared is always going to be positive. If a or b is negative, then the middle term here, the green 2ab, that could be minus. So that could be a minus, it could be a plus. Depends on if a or b is negative. And b is negative for number 3. So let's go ahead and look here. So we'd have a squared, right? So p squared. And then it's going to be plus 2ab, but a is p. So I'm going to go ahead and write p. I'm going to write the 2. Right? So 2p. Notice I didn't write the sign in between them yet. 2, a is p. B is negative 1. So if I put a 1 right here, I need a negative there. So basically, I don't really need this 1 because I'm going to be timesing it by it. Right? So it's like minus 2p times 1. So minus 2p. And then negative 1 squared. So b is negative 1. You include the sign in between. B is negative 1. So negative 1 squared is positive 1. And that's basically my answer. Now, I mean, I don't know if I'm going to box this because you would maybe want to write it as p squared minus 2p plus 1 and not have the times 1 thing in there. So I don't know if I'll box that, but in the future I will because I'm going to kind of just skip right to the answer here. And that's basically how this whole worksheet is going to go. You just need those 2 little formulas. Now, you don't need them, right? So like I was saying before, if you just know how to multiply out polynomials by foiling or whatever, then you're good to go. This is just some icing on the cake kind of stuff. So if you need to know how to multiply polynomials, just any kind of polynomials, I actually have a video for that too. You can scrub to the end of this video and you'll see a link at like the bottom left for a video on how to do multiplying polynomials, and then at the bottom right you should see a link for the whole playlist. So there's a whole playlist of me just working out all of the Infinite Algebra 1 Kuta software worksheets, right? So any kind of worksheet you might do in Algebra 1 or in later grades when you're kind of recapping Algebra 1. Okay, so let's go ahead and move on. Number 5 and number 6 are both squares. Let's use the square formula. And I'm going to switch back to another color here. Let's do green. So x is a. It's x squared. The sign in between is negative, so I'm going to have a minus, right? And then it's going to be 2 times a times b. Okay, so let's write this out. So 2ab, right? So 2 and then a and then b. Now, if I put this all together here, I would get minus 8x in the middle, right? So the formula says 2ab, 2a is x, b is negative 4. I put them together and I get negative 8x, and then the last term is going to be negative 4 squared, which is 16, positive 16. You square a number, you get a positive. All right, any real number, that is. Okay, and there's the answer. All right, so that's actually the answer for number 5. And same thing for number 6. So n squared, this is going to be a plus this time, right? So 2ab, that's going to be 6n plus 9. Right? You just kind of follow the formula. And there's always a fallback to just doing FOIL. But again, I'm not going to do FOIL here because I already did a whole other worksheet where we would talk about foiling and some other kind of methods for distributing stuff. So that's not going to be the focus here. It's just going to be the focus of doing either conjugates or squares. Right? So number 7, is that conjugate or square? Yeah, conjugate. So we do the conjugate thing. We're switching back to the conjugate thing where we do a squared minus b squared. And then we're done. That's a 5, by the way, 25. Here, squares, so we're going to do a squared, and then it's going to be plus 2ab, but it's going to be 2 times n times negative 5. So that's going to be minus 10n plus 25. Okay, so I did that part in my head that time. I didn't write that one out. Now here's how you could do it. What you do basically is instead of 2ab, if you reorder it, normally it makes more sense to do b times 2 times a, right? So when you have 2ab, what that means is 2 times a times b. But it actually kind of makes more sense, if you're going to do it in your head, it's going to make more sense to start with b. Start with the second term, double it, and then stick the variable on the end. Okay, now we're going to have more than just a variable for a in the future, now that we're getting a little bit more complex here with number 9 and so on. But normally, that's how you want to do it. You want to start with b, double it, and then tack the variable onto the end. Okay, so that's it for that. Now we're moving on to where we have a little bit more complex stuff going on here. We still want to square it, but now there's like a number and a letter that we have to square. So it's 2 squared and k squared squared. K squared squared is k to the 4th. When you square a square, you're multiplying, so it's like not, it's not like 2, it's not like k to the 2 to the 2. It's like k to the 2 times 2. I don't know, if you think about it too much, it might be more confusing than not, but that's a k. It's totally a k. So 4k, 4. 4k to the 4th power. And then let's do that little trick, right? So it's going to be plus, because it's 1, right? So 1 times 2. So 1 is b, so we start with b. Remember we said start with b. b times 2 times a. So b is 1. Nothing happens there. Times 2. Okay, so we have a 2 now. Times a. Well, a is 2k squared. So it's 4k squared. And then plus 1, because 1 squared is 1. And that's it for that one. Okay, back to conjugates. So we're going to square the first term. 64. 8 squared is 64. A squared squared, right? When you square square, you get a 4th power, right? So a squared, the whole first thing squared, minus the second thing squared. Now, there's 2 different b terms, if you noticed. So it's like I have 2 different b things. Like I either have a positive or a negative 4, but it actually doesn't matter. because whether you square the positive 4 or the negative 4, you'd get a positive 16, and then you're supposed to put a minus sign in between them anyways. So it doesn't matter which one you pick. Okay, on to number 11. A squared is just 4. Then we do b. Well, in this case, the thing with the variable in it is like the second term, so I guess it doesn't really matter too much. Both of them are positive, so it's going to be positive. Right? Basically, if they're both positive, then you'll have a positive. If they're both negative, you'll have a positive, right? Because positive times positive, negative times negative, integers. So then we have 2ab. I'm gonna go in the same order as I normally did at first. 2 times a times b. So 2 times 2, a is 2. 2 times 2 is 4. Times 5 is 20 in squared. Right? And then the last term squared. 5n squared. 5 squared is 25. N squared squared into the fourth. All right, moving on. Conjugates again. So I square the first term, 9x squared, minus square the last term, 49, and we're done. Right? All right, let's see here. So we'll switch colors. I've done pretty much every color except red, so maybe we'll do some red here. All right, conjugates again. Square the first term, minus, right, so 3 squared, and then 7v squared squared. 7 squared is 49. V squared squared. When you square a square, you get a 4. So 49v to the fourth. Right? Conjugates again. So we square the first term, 49 v to the fourth, minus 6 squared is 36. All right, on to the next thing. This is a square, not a conjugate, right? 13 and 14 were both conjugates. This is a square, so we square the first term, plus, because there's no minus signs in sight here, 2ab, so 2 times 2 is 4 times v, so 4v plus v squared. And then over here, conjugates again, so we're going to do a difference of squares, so we're going to have the first thing squared, 36v squared, minus 9. And we're pretty much already done. We've got just a few more here, and then we get to the answers here. So just until 26. So a few more, but we're pretty much already rounding off our answers here. I'm going to start switching colors a little bit more. 8 squared is 64. Oh, and by the way, these are conjugates, so I'm going to square the first term. 64a to the fourth minus 4. Boom, done. This is a square thing, so we're going to square the first. 16a squared. 2ab, so 2 times 7 is 14 times 4 would be 56. So 56a. You can also do 2ab. So 2 times 4a would be 8a. And then 8a times 7 is 56a. It doesn't really matter what order you do it in. Just whichever way makes the most sense to you, I guess. Plus, and then 7 squared is 49. All right. So we do it again here. We got squares. So I square the first term. 2ab minus, because I have a minus sign this time, minus, and then 2 times 2n is 4n. 4n times 7 is 28n plus 49. Remember that last term is always going to be positive. All right. Let's switch to like a light green maybe. Now we've got some extra negatives. Remember, that's not really going to affect anything. These are conjugates still, so I'm still going to square the first term. Negative m squared is, or sorry, negative m quantity squared is still m squared. It's still positive m squared, because when you square a negative, you get a positive. So that's still m squared. Minus, and then 5n squared is 25n squared. All right, so don't let those negatives throw you off here. Another conjugate. 7 squared is 49. U squared minus 16v squared. We'll switch colors again. Kind of just jumping around now. Negative y times negative y is y squared. Minus, we have conjugates, so I'm going to multiply the last term, square that out, 9x squared. All right. We have a squares thing again. So I'm going to square the first term. Negative 9 squared is 81. X squared squared, so x to the fourth. Oh, I said fourth, but I wrote 2. Let's fix that. There we go, 4. 81 x to the fourth. So if the sign in between them is negative, then you'll have negatives. Well, actually, it would be, well, no, you would have a positive because they're both negative. Because it would be 2ab. So 2 times negative 9x squared. So negative 18x squared. Negative 18x squared times negative 10y. So negative 18 times negative 10 is positive 180. And then x squared y. Ooh, that was a doozy. Okay, let's do that again. So it's 2ab. It's 2ab. Right, so you're literally doing double or 2 times each thing multiplied by each other, right? And then the last term is going to be positive as well, actually. That's going to be 100 y squared. Ooh, okay. So, oh, not the highlighter. I want a different color. Let's do brown. Because why not? This one's squared, so we square it. I wrote 4, but I meant to write 16. 4 squared is 16. 16u squared. And then plus 2 times a times b. 2 times 4 is 8. 8 times 9 is 72. uv. And then 9 squared is 81. v squared. And that's it for that one. And you know what? I'll just let's just switch to a darker shade of brown maybe, so it's a little easier to see. And then we'll just round that off with that same color brown there. So this is conjugates again. 49 u squared minus 36v squared. And then this one, it's squared, so we're going to square it out here. Negative 6x quantity squared, so positive 36x squared. And then we're going to have a plus, because it's going to be 2ab. 2 times a times b. A and b are both negative. They make a positive. 2 times 6 times 7. Well, 7 times 6 is 42, and if you double that, you get 84. So 84, and then xy squared plus 49y to the fourth. And that's it. That's it. That's the whole thing. So you can check the answers here. What I'll do is I'll do like a slow scroll here so you can see the answers. You can also Google these answers. You can literally just look at the name of the worksheet, multiplying special case polynomials. Google it. You'll find it. You scroll to the second half of the worksheet, and that's where the answers are. And you can check the answers yourself. So you can always do that. You don't need to use one of these videos to do that. But if you want to have an explanation of how to work out each of these problems with work provided for some, most, all, it depends on the worksheet. This one, I guess, I did a little bit less work than I normally do. But it was a special case thing. So we're using a special formula to work out each one. So the whole point was that we would have to do less work, less showing of work than we normally have to. So that was the whole point of this worksheet. I did a lot more showing of work on the last one because it was just multiplying out polynomials and not like special case polynomials like this one was. All right? So if this has been helpful, instead of doing a like or a subscribe, which, you know, I'm not going to stop you, if you want more free resources like this, you can check out my channel. You can check out the worksheet that should be popping up, or the link to the playlist that should be popping up at the bottom somewhere by now. And you can also check out my website, myersmathematics.com. The link is in the description for that as well. I've got tons of awesome free resources on there. Like, for instance, one of them being the 5 math mistakes everyone makes and how to avoid them, which is an awesome free guide that's on my website. That is on the front page. You'll see it when you first get to that front page there. And you can download that no matter what math class you're in, or if you know anybody that just wants a guide to not getting math problems wrong, aka getting math problems right. If you know anybody that could benefit from something, like a quick guide like that, or just other free resources too. Like I'll have books, just whole books eventually, things like that. So lots of cool things happening on my website, Myers Mathematics. Go check it out and let me know what you think. And I'll see you guys in another episode real soon.